We're going to be studying direct, inverse, and joint variation, which is a relationship between two different quantities. Direct variation has a constant of variation, so we're going to use the variable a. If a is a constant of variation, then y varies directly with x if y is equal to a times x. Real life examples: the more you study, the higher your grades. The more money you save, the better car you can buy. The more money you make, the more taxes you pay. So as one quantity increases, another quantity will also increase. So what we're going to be doing is writing the model y is equal to a times x, which involves finding what the constant is. And then we're going to be using that model to answer questions. The variable y varies directly as x. It's all about the y. When you have a variable listed first, it's going to be y equals directly as x, and then a times x. And y is equal to 9 when x equals 3. Write an equation that relates x and y. Then find y when x is equal to 14. So the first thing we're going to do is find a. We're going to begin by substituting in what we know, which is y is equal to 9 and x equals 3. So y equals a times x. And then we are going to solve for a. So a is going to be 3. So whatever x is, y is 3 times as large. And we're going to write our model. Y is equal to 3 times x. Now that we have a model, we can solve any problem that has that same relationship. And we're going to answer this question. When x is equal to 14, what is y? And that would be 42. Next, great white sharks have triangular teeth, where the length of the body varies directly with the length of the side of a tooth, not teeth. If the length of a shark is 290 centimeters and its tooth length is 2.4 centimeters, write an equation relating the body length to the tooth length. So again, we still need to find the constant of variation. This is saying that the bigger the tooth, the bigger the shark. So we're going to find our constant. B is equal to a times t. And we're going to put in what we know for one shark, 290 and 2.4. Then we're going to get a is about 120.8. And so our model for this is b is equal to 120.8 t. And that would be a good estimate for most any shark. So for great white sharks, find the approximate length of a shark that has a tooth length of 5.8 centimeters. So we substitute in what we were asked, 5.8, to find the approximate length of our great white shark. Inverse variation, it's not direct, which means as your quantity gets larger, the other one's going to get smaller. Or as your quantity gets smaller, the other one's going to get larger. We're still going to use the same constant. If a is the constant of variation, it basically serves the same purpose as slope. Then y varies inversely. Before, your constant and x multiplied. Now your constant and x are going to divide. Real life examples. You and your friend are on a seesaw. You weigh exactly the same. And assuming that your seesaw is perfectly balanced, you can sit the same distance away and stay balanced. Another example. If you have a new friend and your friend weighs more than you do, then that friend is going to have to sit a smaller length away from the middle of the seesaw than you are. So we're going to set up a variation with y varying inversely as x. We're going to find a. So y is equal to a over x. We're going to write an equation that relates those two. So when x is equal to 1/3 and y is 15. So I'm dividing by 1/3. We can either multiply by the reciprocal to clear that out, or we can multiply by the 1/3 and cancel. And so a is going to be 5. So here's our model. Y is equal to 5 over x. And we're going to substitute in -10 for x. So y is -1/2. Joint variation. Joint means more than one, and this in particular is more than one direct variation. This occurs when a quantity varies directly with the product of two or more quantities. An example of this is the volume of a cube. If you're writing a small cube and you want to make it bigger into scale, if length increases, so do the other two dimensions. Now this example is not a cube because of this negative right here. And we are going to set this up. So it says the variable z varies jointly with both x and y. So what we're going to be using here is z is equal to a times x times y. Only one constant is needed. And we're going to substitute in what we know. So we can find the a, solve for a is negative 3. And then we're going to answer the question to find z. We're going to substitute back in our negative 3. There's our model right there. We're going to put in x and y and solve for z. Now some mixed variation examples. This is just going to give you some practice on writing these equations quickly, inversely. As r gets bigger, s is smaller. That's going to be a division. R is equal to a over s. Z varies jointly with x and the square root of y. These are both going to, as these get bigger, z is going to get bigger. So z is equal to a times x times square root of y. Q varies inversely with the cube of p. And yes, you're going to have to cube the p. Don't just write the q there, the p there. And then the last one, z varies jointly with u and v and inversely with the square of w. Yes, it happens. You can do both. So we're going to multiply by u and v, and we're going to divide by w, and make sure you have that constant of variation. The next, we have Boyle's law. It states that for a constant temperature, the pressure P of a gas varies inversely with its volume. Pressure is measured in atmospheres. The sample of oxygen gas has a volume of 50.25 cubic milliliters at a pressure of 20.6 atmospheres. We want to find the constant of variation. We want to find A. So inverse means you're dividing into your constant. And then we're going to find A. And it comes out to be 1035.15. So we're going to write the equation that relates these. So we have P is equal to, but we're looking for V. Well, if P is inversely related to V, then V is also inversely related to P. It works both ways. Find the volume of the oxygen gas if the pressure changes to 15.2 atmospheres. And we get 68.1 milliliters.